I have a little bit of energy, and I'm very excited to be up here. Very honored. There's humans in the room. If you're an alien, please identify yourself. Are you from Mars or are you from Uranus? Anyway, I just wanted to welcome you all personally, myself. This is Adrian. I hope you have a good time today learning a little bit. This is my SAT hat, and I'm very excited. Please come by and see us at the Aerospace Village, and I'll let Adrian start, but I always like to give a little kick in the pants before we start. So welcome, everybody, and peace to everyone.
Yeah, as you can tell, he has all the energy on the stage right now. So yes, thank you everyone for being here this morning. Today, I want to introduce you to something that sits at the intersection of space, making, hacking, and education, the AMSAT CubeSat simulator, or CubeSatSim. It's a low-cost satellite emulator that runs on solar power, sends real UHF radio telemetry, sits inside a 3D printed frame, and can be expanded with sensors and modules. In short, it behaves like a real satellite, but you don't have to send it into space. This project is sponsored by AMSAT, the nonprofit radio amateur satellite corporation, whose mission is advancing space education and experimentation. So why CubeSatSim? A surprising number of real CubeSats are DOA, dead on arrival, when they reach orbit. It's expensive and sad, so this is where we get CubeSatSim. Instead of starting with a full flight model, teams are able to make mistakes safely, debug real systems, understand power, communications, and telemetry, and practice core cybersecurity principles. So what is CubeSat? CubeSat is a physical satellite emulator. It includes solar power panels and batteries for real power management, UHF radio telemetry, which you can receive with amateur radio equipment, a 3D printed CubeSat frame. This is only the frame for on the ground, not for in space. A microcontroller brain running flight software for the ground control station, and it's expendable with sensors, GPS, cameras, and environmental modules. It's open source, low cost, and buildable by individuals and classrooms. So how is it being used? CubeSat is already in the wild. It's being used at classrooms and universities, STEM education programs, CubeSat project teams preparing for real missions, amateur radio training, and public outreach sessions such as this. Students can track telemetry, analyze data, modify firmware, manage power budgets, and simulate real missions. It's a training satellite for future space engineers. So why does this matter? CubeSatSim lowers the barrier to space. You no longer need $1 million budget, a government contract, or a government lab. All you need is curiosity, a willingness to learn, and a soldering iron. Or not, there's also a non-soldering kit too. This tool empowers the next generation of satellite builders and helps ensure that when we do launch, it works. If this sounds interesting, you can check out full documentation and some additional videos online at CubeSatSim.com. And now Henry's going to walk us through how we can use CubeSatSim for cybersecurity.
Woo! Give it up for Adrian, ladies and gentlemen. All right. So a couple things also I wanted to add niblets to the CubeSat. I've built 7 of them. I work at a college in California, and it's been such a wonderful experience. There's 2 models that you could get. One is $350 that's all put together, meaning soldered. The other one gives you a full bill of materials, so you can actually go to Amazon or other places, Mouser, and all these different places to be able to purchase it online and do it yourself. There are 136 solder points. Heavens to Betsy. So if that's not your giddy up, then maybe get the 350 that you can put together that has all the soldering points done. What I find really interesting about the CubeSat, also working with young people, I've also done it with high school students. They can do it as well. The soldering, a little sketchy because you have to be practiced because there's components that you don't want to get heat, we'll call. But I think it's really a great experimentation to learn about space, right? Right now, we have a huge problem because the space industry, the legacy or tribal knowledge folks, are going away. They're retiring. And we need more people like you in this. And I just find that when you learn the basic knowledge and understanding of CubeSatSim and what it shares with you, the camera, it has telemetry, which means basically, you know, it can do fun stuff with the radios. It has a ground station. These are all things you have all touched before, Raspberry Pi, Pi Zeros. It's a great way to do this. He also has 3 already up in orbit. So about 8 years ago, he popped a few of them up there so he could see. Not the one that we have at Aerospace Village, because it needs to be hardened for radiation and different things to make sure it's space ready. But my point is, I'm just coming back to building the CubeSat with young people. It's a really, really great thing to try to actually go through all of that and understand how it works. One of the other strange, cool things is it has a camera on it. And in that camera, it actually shows when you're taking a picture in space, it takes a little while because it's passing around the Earth. So you don't get the data immediately. Kind of like a long time ago when our modems fired up and it made all that hibbity hoppity noise, and you're waiting for the damn page to load. It's similar to that. You have to wait a little while to get those pictures. So anyway, CubeSatSim, really, really great thing. Why security? Great question in the back. Thanks for asking. So I think what's really cool about the satellite itself and the cybersecurity components, I'm going to talk a little bit about today F-Prime. F-Prime is JPL, NASA's flight software. And I want to tell you, a lot of people don't realize it's open source. In the house, everyone, let's say open source.
Open source.
Woo! Go team. Love it. So, not yet. So, utmost importance, I wanted to share with you a couple things about what it does. You're looking at assessments, and what we're going to talk a little bit about today is F-Prime. F-Prime, the flight software, is vulnerable. Why? Because it's open source and a lot of people are hard coding and helping build it, right? And so what's really cool is you can use that maybe to mimic a rover or other types of robotics you can use it for, and it does other things for satellites as well. So you can use it for multiple different disciplines. And what's really cool is the hijacks that have been happening 2008, 2009. I'm just going to give you a little bit of history of some of the things that have happened in the past. And the thing that's interesting to me about this is for a really long time, no one was hacking satellites. Why? Because we all had the word trust. Nations trusted each other, and also because we were analog. It was a little bit kind of out of the realm for hackers or script kiddies to actually try go listen to satellite packets, capture packets, and or maybe listening to people talk. And I'll talk a little bit about San Diego in just a second. But in November 2011, they potentially, from a nation state, compromised the highly privileged users at NASA's JPL, granting them unrestricted access to the ability to install malware and steal data. So when this happened, and I'm telling you this because JPL is very embarrassed, right? They don't want to have that happen. Nobody wants to have anyone doing some of this bad stuff. But it's really critical for you as a normal user that we want to get more people interested in satellites, right? And space. All those people are retiring, like I spoke about a little bit before. Okay. So I got a bitchin' Camaro picture. Sorry to show my hand in the house. But this cyber attack, I wanted to give you kind of a really cool visual. And this happened 22. We talked about it a little bit last time I was here, but some of you don't know about, and maybe you don't know exactly what happened in these things. But basically, this cat was a critical communication problem because they were using a specific satellite for their comms, for their communication. And what's cool about this picture is it starts out in the internet. We all use that on a daily basis. It's really, really important. We use it to go places, you know, our GPS, all of the satellites that we actually use, we use on a daily basis. If we lost GPS, all of our critical systems would be seriously hammered. Not just trains, planes, all those other things, our hospitals, lots of things use our GPS. And it's really critical to keep our whole entire world using. So back to it first, the internet part, right? Then you talked about the ground station. The ground station is, in my opinion, the most hackable thing. However, some places don't really put a very good fence around it, right? Or a double wall so that you can't actually get in there. Because if I were a hacker and I was trying to get into a place, the ground station is actually where I would go. And the only reason I'm telling you this is because I'm trying to help you understand how we want to protect that. So we need to do a better job also making sure our ground control stations are highly secured, meaning not just the fence with a little barbed wire that I can hit the opposite through, but other ways to make sure that there's no way for people to get in. So what's interesting about this is Viasat Networks, that's the management software on their remote routers, infected the target terminals. Notably, the satellites were misused this task to deliver malicious commands to the target terminals. What was interesting about this was there was a cause of Starlink. Starlink, if you don't know, is a mass-produced global network from a company that's basically putting the internet where people need it. And this was an example where it actually was helpful for them to actually go through. So then what happened is actually the actual ground station, when you point up, it goes into orbit, then it goes to the end user, and then over here, you have the link that talks back to the user segment, and the user segment saying that there was this bias that happened that could do to protect. There was nothing to fix it, right? There was no way for them to just reboot something or get it to run quickly. And then the last, you into the modem, and once you get into the router packets and that component, you are SOL, shite out of luck, if you will. Okay, next one. So what's also interesting to me is hacking satellites and what does it look like? So adversarial assessment, and there's a great paper on that. I'll show that picture in a couple seconds, but there's a really good paper that JPL used. And I used this to teach high school as well as college students what is hacking satellites. And a couple things up here that F Prime has is they took their own open software in 2024 and seriously looked at what vulnerabilities were there and tested against it. So this is the people creating their software, right, and actually going in and trying to hack it. It's beautiful. And then the best part about this paper is the word mitigation. How do you fix this stuff, right? And so what's really cool about this is the CubeSat, and I'm going to ask here really quick, in this room, how many people know what DOS is or a denial of service, right? Okay. What's cool about this is there's a crossover between what your current knowledge is and getting into space. Some of the network knowledge that you all know and understand, or the basics of cybersecurity, are also in space. And I think what happens is it scares a lot of people and they think, oh, you know what, I could never do space. That's too hard. Orbital mechanics, I can't handle it. It's too much physics for me, those types of things. You can. And there's ways around doing that and understanding some of those things. So I just want to know, like, the crossover is really cool because I'm trying to get more people interested in space and letting you know you can toy around with the networks that understand how space works. Some of the Wi-Fi stuff that you use, they use specific bands that, to give you an example, the CubeSat is on a 439.94 megahertz. That's a teaching tool band that everyone uses when they're making satellites or monkeying around with satellites. The FCC gave us those ones so that we could play on safe areas. So understanding wireless, how many people understand wireless in here, right? So some of those components are going to cross over in that realm. Okay, next. So this is it. Please come by. You can take a picture. It's just DTS, I like to call that to my students. Google that stuff, but if you're with students, you can say Google that shit. So anyway, adversarial assessment of F prime. The cool thing about this is maybe a 10-minute read. This is what I absolutely make anybody that I'm teaching about cybersecurity and satellites read this. And it was done in 2024. This is the one where they actually tested their own software. And the beautiful part is they give you the mitigations on how they fixed it. It makes me tingle. If anybody tingle, that's amazing stuff, right? Just getting excited about this stuff. So again, please take a picture. You can just GPS that adversarial assessment of F prime. And F prime, the name comes from any math wizards in here. Yeah, exactly. F prime. So they thought that was really funny when they were designing it. I was talking with people screen. Okay, next slide, please. Everyone doing okay in here? Cool beans? Interesting? Okay, awesome. Okay, so again, I want to give a shout out and thanks to Alan. He's the coolest cat on the planet. been doing wonderful things with the CubeSat for a really long time. You can give him, I got his permission, you can email the dude directly. What's also cool about this AMSAT project, if you're an educational institution or you're a cool trusting human, he will send you the whole kit and caboodle, the whole flipping box with lessons for 2 weeks, and then you send it back. And he pays for the postage. Woo! Let me hear it for Alan. Oh, yeah. Come on. So I get choked up because there's not enough humans out there doing stuff like this to help young people and other people get into that space. Okay, next one, please. Aerospace Village, so very excited. We are this great, cool group. We inspire, we want to change lives and get some of you into aerospace because we're losing those people. And I know I said it 2 or 3 times, but the Aerospace Village, we go all over the planet. I just happened to go to Tokyo this November. What? Awesome sauce. I've never been to Japan. It was the greatest thing I've ever done. It was awesome. I went to Tengu Con as well as Code Blue. It was the most amazing experience I've ever had. And learning from hackers from other countries is really cool. Those people that I met over there asked the most provoking, thought-provoking questions and futuristic things that I could not even imagine or answer. It was really good to share information and connect with other humans. So again, we try to make sure we're inspiring the next generation of humans. This is us at DEF CON. We're always at DEF CON, but we do a bunch of other conferences as well. And again, this is our first time. Be loved, and thanks to Jamie and all the Cactus Con crew for honoring us and letting us come here and be a village. And if you did not come to the Aerospace Village, please come by and get a sticker because I'm not taking a sticker. All right, next step. Badge light. OMG. Let me hear it. OMG. Woo! Okay, so this beautiful baby we created last year at DEF CON, and oh man, it actually tracks satellite. Let's say it in the whole room. Satellite. It has a tracker on it. It's using Wi-Fi and other components. It also, and I would say this backwards so someone can help me, ADVS, but basically it allows, did I say it wrong? Thank you. It tracks planes. So not only does this badge track planes, satellites, and it has a Game Boy emulator. Let's say Game Boy! Woo! And it has a beautiful round screen that you can put your own GIFs if you're in the GIF world, or if you're a GIF person, you can put them in the GIF. Anyway, very fun, has an SAO, and I just want to say, why do we do this? Badge life is my life, and I'm part of the Hard Hat Brigade as well, some of the crew in here, very lovely. I want to transfer. We take any hat. It does not have to be a hard hat. Come in and join the group. But Aerospace Village wants to promote. So these are the type of badges and things that we make. Last part, this little baby one on here is Moonlighter. At one DEF CON, we did Hack-A-Sat, where we actually hacked a live satellite with the Air Force and the AFRL, and great humans did some cool things learning how to satellite hack live. And while it was at DEF CON, 2 passes happened, so the 6 groups that were actually doing it only had 2 tries to be able to turn on a camera, do some cool stuff, but we're working on that. Because of leadership and different things that are coming down the pipe, we're trying to change that and get more money to do another Hack-A-Sat. But I wanted to mention our badge life. We also, because we do aeroplanes as well, we have a great setup right now, bricks in the air with Dan being all the way from a far, far place with the White House. Oh, almost done. Okay, Jimmy. So, next slide. Go. This is Play a Satellite Game. 4 college kids wrote a Unity program. This will teach you the basics of satellite hacking, probably in 15 to 20 minutes. I know all of you can do it. Just click the right answer. It's kind of like really good stuff, and you'll enjoy that. And come see me if you didn't get to take a picture, because I have 44 seconds. Next one.
Those QR codes are also on the tables at the village.
What was that?
Those QR codes are also on the table at the village.
Yeah, at our Aerospace Village. We're over in the vendor area around the corner. We also brought an alien and some Star Trek folks you can take a picture with. I'm really honored again. I want to give Adrian a hug for coming up in here and shake the world for me and helping a good stop. Thank you very much.